Okay, where we left off is trying to estimate the total cost. We built in the cost per task that actually gets done, the $1 that we're going to pay the kid per task that he does, and also the cost of tasks that don't get done, the cost of my own embarrassment. And what we're left with is a kind of tricky piece of this, which is deciding whether or not I want to apply this multiplier, this that it would multiply the per task rate by 2 if all the tasks are done in a given week and they're done well. Okay, so since this is a little bit tricky, I like to do this using intermediate steps. I like to create some variables that help me figure out whether this is true or not. So I'm going to add a couple of rows here. Okay, and let's create a series of flags. Flag, and what I mean by this is a binary variable that's going to be set equal to 1 if all tasks are done, 0 otherwise, and a second flag, which is equal to 1 if all tasks are done well, 0 otherwise, and then this last flag, which is going to multiply these two, which is equal to 1 if all tasks are done and done well, 0 otherwise. 0 otherwise. Okay, so these are not just values, input parameter values that we want to fill in. These are things that we want to calculate as a function of what's up here. So the first one is pretty easy. Are all the tasks done? 1 if yes, 0 otherwise. So we're going to use if statements to help us do this. Equals. Okay, if, and remember I need the logical test first. The test here is if this value, the number of tasks not completed, if that is equal to 0, that means all the tasks are done, then I want to return a 1, otherwise I want to return a 0. Okay, so in this case, there's 3 tasks that are not done, so this flag gets a 0. Not all the tasks are done in that week. The next part of this is, are all the tasks done well? Well, that's pretty straightforward. That's a function of this parameter value. Are all the tasks done well? So this, using an if statement, is equal to if, the logical test, this value, if that's equal to 1, okay, then all the tasks are done well. The tests are done well, high quality. The tasks are done high quality that he does. So we would return a 1. If it's set equal to 2, then the tasks he does are not done with high quality, and we want to return a 0 here. So by converting these values, essentially what I'm doing is I'm processing values up here, this one that tells me how many tasks were not done, and then this parameter value that tells me whether the tasks that the kid did were done well, high quality. If I process that information and get these two flags, then I can multiply these together, equals this times this. If I multiply these together, it's only going to equal this flag, the flag for all tasks, the flag that I want to be equal to 1 if all tasks are done in the week and they're done well. This is only going to be 1 if both of these other two flags are equal to 1. And if you multiply them together, that's true. So the only way for this flag to equal 1 is if this equals 1 and this one equals 1. If either of these equal 0 or both of them equal 0, then this is going to be 0. Okay, so now I have a flag, an indicator variable that tells me it's only going to be 1 if all the tasks are done well. So now I can use that in my cost function. Now, what I want to do here is I want to essentially multiply C7, that's my rate per task, that $1. I want to multiply it by the multiplier if and only if this flag is equal to 1. So let's use an if statement within our function here. So I'm going to say if this flag, okay, is equal to 1, then what I want to do is I want to return everything that I had here, right? But now instead of just the C7, I want to multiply that per task rate by the multiplier, which is here, okay, and then everything else should work. But if the condition, the logical condition is not true, this flag is equal to 0, then what I want to return is the formula that we'd had before. I'm going to copy it, use it again, copy, paste, but I want to take out that multiplier. I don't want to multiply the multiplier if the flag for all tasks being done in the week and done well is not equal to 1. So I want to return what I had initially had in my cost formula. Okay, so let's test it. It's really important to test and make sure things work the way we think they did. All right, so here in this case, the kid completed 9 tasks and didn't get 3 completed, so there's some cost to me of embarrassment there. And he did calculate. He did get all the tasks done well. This is a 1, but he didn't get all the tasks done. So I only paid $1 per task, not $1 times the multiplier of 2, for a total cost of 12. Now, if instead he gets 6 tasks done, okay, he could do 13. I only needed 12, so I want to pay him for those 12. There are no tasks that were undone, so I don't assess any cost for that. So that's $12 so far. But notice that my cost is $24. Well, since all the tasks were done high quality, because that's what I've got here with a 1, that I've applied the multiplier. So I'm paying him 12 for 12 tasks at $2 per task, $24. So that seems to work. But let's test it one more way. If this wasn't a 1, not all tasks were done well. They were done. There's no tasks left over. But if the tasks aren't done well, then this value would take on 2. It would be 2, not 1. Okay, and look at that. My total cost estimate goes down to 12, as it should. So I think my base case model is working pretty well. You can, I'll post this model up on Sakai. You can play around with it. Click in type in different numbers, and make sure that you test it and that this cost calculation seems to work pretty well. All right, I am going to stop the video and then start up again talking about Crystal Ball.